Okay, in this video I want to look at the operation of the control relay and look at the ladder logic diagrams and talk about how they work and how the connections work so you can get a better understanding for wiring it up and using the control relay. Alright, so in my other video I talked about different types of relays, different coil voltages, and the contacts and the manufacturer's terminal numbers, so I won't get into all that. With this video I want to focus on the wiring and how to use it. Alright, so in this first example that I have here, I just have two switches and the relay. Okay, so that's what I have in my diagram. I have a normally closed stop button, a normally open start push button, and the coil of the relay. That's all I'm using here. So I have my power coming in from L1 into the stop, which would be this wire here. So that's coming from my power source into the stop button. Then I come out of the stop button into the start button. So that's this wire here. And then I come out of the start into the coil of the relay, which is here. And then I come out of the relay back to the other side of my source, and that's this wire back here. Okay, so very simple, straightforward. So this example that I'm doing here is a 24-volt relay because it's just easier to do in the office here. But this L1 and L2 could be an AC supply off of your controlled transformer. Okay. But the power source is only affected by the coil of the relay. So you have to make sure the right coil voltage matches what your power source is. But again, what I'm focusing here is the control wiring. So looking at this diagram, I see that I have two switches that control the current flow to the coil. And so the stop button is normally closed, so that means I do not have to push that one. The start button is normally open, so that is currently breaking the path of current flow. So that's why this coil is off right now. So when I push the start button, you can hear it pull in, and you can also see the indicator light here. So when I close this normally open contact, that completes the circuit and the relay can energize. Now if I hold down that start and then I press the stop, it cuts off. Okay, because now I'm making the start button but I'm opening the stop, so the relay is off because I'm breaking the connection here. So it's all about controlling current flow to the load, and that's what you're doing with motor controls. Okay, so with this circuit, the start is controlling the operation here, but the stop is really not necessary with this example because push buttons are momentary devices, as I talked about in my video about push buttons. So with this, I don't really need the stop, but we don't want to have somebody hold down this start button continuously for this relay to be on. All right, so what we need to do is add in a memory circuit or seal-in circuit. Okay, and that will allow us to keep the relay on without having to hold the start button down. So that's what we're going to do next. Okay, so now I have added in a seal-in contact or memory contact. So what I've added here in my diagram is I've added a normally open contact that is being controlled by the relay, and that is wired in parallel with the start button. Okay, so the two wires I've added here, the first one is over here. So I've come off of my coil into the contact. That's what that little jumper is right here, into one side of the normally open contact. And then the other side have come out and went to this input terminal of the start button. So this has to be in that jump between the stop and start. So I can either put this wire to the right side of the stop button or the left side of the start button. So I put it on the left side of the start button. But either one will work because electrically they are the same point. Okay? So now what happens when I energize the relay, all the contacts change state immediately. So this contact will close, and that will provide an additional path for current flow, so that when I release the start button, this coil will stay energized. So I hit the start, coil pulls in, contact closes, and now when I let go, there it goes. Now when I let go, the relay stays on, okay? So it stays on because that contact is closed, so now current can flow through the stop button, through the contact, and keep this relay on, even once I open the start button. So now the stop button comes into play because now that I have this seal in, I need a method for shutting this relay off. So by hitting the stop button, that breaks the path for current flow. The coil de-energizes, so therefore the contact's open. So now we don't have that extra path around the start. So when I release the stop, the relay remains off. Okay, so that is a common wiring practice of using a seal-in circuit around push buttons to keep loads on even after you release a switch. Okay, so here I'm just using it with a control relay, but we can also use that with a contactor or a magnetic motor starter as well. Okay, another thing I want to show you with this is that the memory circuit or seal-in only works, if power is applied to the circuit. So what I mean by that, if we were to lose power to this circuit with it on, so let me just do that. I'm going to disconnect my power supply power cord here. All right, and you see it cuts off. When I plug power back in, which it is now, the relay does not automatically come back on. So I have to again push my start button to operate the circuit. Okay, so if you lose power, the coil de-energizes, so the contact's open, and therefore the memory or seal-in is lost. Okay, so that's how the stop-start with memory operation works. All right, so next we're going to use some additional contacts to do some additional control with some pilot lights. Okay, so now I have added in 2 pilot lights to my circuit, and so I have my first pilot light, which is a green pilot light that's going to a normally open contact, and then I have a second pilot light, which is my red one, going to a normally closed contact. So what I've added to my circuit from the previous example is I've brought another additional hot wire from my source, which is this one right here, into my normally open contact, and then I come out of the normally open, which is this one, which goes over to my green pilot light, and then the bottom one down here is my normally closed, which goes over to the red pilot light, and then the 2 go back to L2, which is the negative of my DC supply in this example. All right, so what happens here is when the control relay energizes, all the contacts change state, so the open contacts will close and the closed contact will open. So that means this contact will close for memory, and this contact will close to turn on the green light, and this contact will open to turn off the red light. So when I hit the start, green light comes on, red light goes off. Okay, so I can use this to indicate the status of a motor or a part of the machine, to indicate that if it's on or off. Okay, so I hit my stop, coil de-energizes, all the contacts go back to their normal state, so the red light comes back on and the green light goes off. Okay, so this can show that the motor is stopped, and then the green light can show that a particular motor or whatever type of load you want to indicate is on. Okay, so I'm using an additional set of contacts, so I would not want to use the one I previously used for my memory, which is this group of contacts at the top. So I use this one on the other side. There's 4 available here, so I just use the first and last on this relay. So I bring power into one side, and then I use normally open and normally close to my 2 different pilot lights. Okay, so that just gives you a little bit of an example, and hopefully can clear up some of the issues that you may have in wiring these types of circuits up, by being able to see just the components together here and seeing how that works with the ladder logic diagram.